Hello guys, today we shall be looking at how to calculate for shape factor of an ice section, and it's just a ratio of Zp all over Ze. That is plastic modulus all over elastic modulus. Then having established the formula, you just go ahead to write out all the parameters that you are given. From here to here, that is the flange, is 300 millimeter. And if you consider this as a square, this will actually be your breadth. So your capital B is same thing as 300. Then if this is considered as square also, your depth will be from here to here, and that is D. And the distance from here to here is 250. Remember, it's in millimeter. Then you can take in consideration the flange and the web. So if you remove this web, the breadth will now be 300 minus 10, and that is 290. Therefore, your small letter b is 290 millimeter. Likewise here, if you remove the two flange, you have 210 left. Therefore, your small letter d is 210 millimeter. Don't forget, your zp is same thing as 2xx. It means that if you take a moment about the neutral axis, which is the center of this ice section, that the moment about the neutral axis from the up and from down will give you the plastic modulus. Now let's go straight and do it. Zp is equals to 2. So when we take a moment here, let's assume we'll call this x. It means that we are going to calculate the shape that will be left here, then multiply by the centroid of the shape. And we already know that this is 300. And if from here to here is 250, that means half of it will be 250 over 2. That is 300 multiplied by 250 over 2, which is actually the shape of a rectangle. Then the centroid is going to be half this distance from here to here, and that will be the same thing as 250 all over 4. Then minus, what if you remove the web and the flange? How would the shape look like? It means that your b will now be the small letter b, which is 290, multiplied by d over 2, that is 210 over 2, multiplied by 210 over 4. Then your zp will give you nothing less than 1490250. Alternatively, you can use that zp is equal to bc squared minus small letter bc squared, where you already know the value of your bc, both the small letter and the capital letter. So solving with that, you have that zp is equal to the capital letter b is 300 multiplied by this c is the centroid. So when you consider the whole shape, the centroid will be at the center, which is 250 over 2. And don't forget, in the formula, you're going to square it, minus when you remove the flange and the web, which is small letter b, 290 multiplied by 210 over 2 all square. So if you use the same formula, your zp will also be equal to 1490250 millimeter raised to power 3. Same thing here. Then our elastic modulus is equal to I all over y, and the I is equals to bd raised to power 3 over 12 minus bd raised to power 3 over 12. I is equal to capital letter B is 300 multiplied by 250, which is capital letter D, all over 12, minus 290 multiplied by 210 raised to power 3 all over 12. That will give you 166817500. Your y is equals to d over 2, and your d is 250 all over 2. That will be 125. Therefore, elastic modulus will be equal to 166817500 all over 125. That will give us 1334540 millimeter raised to power 3. Therefore, our shape factor is equal to Zp all over Ze, and that is 1490250 all over 1334540, which is equal to 1.12 approximately. If you enjoy watching this video, please make sure you subscribe to this YouTube channel, and also don't forget to drop a comment.